got the right side and the right sides. All the right sides have one boundary, all the left sides have one boundary. And to use a horizontal strip is you need to be able to solve the original definition for x. You need x in terms of y. If that doesn't happen, then you can't use a horizontal strip. So let's this is going to be a bit different than what I have in my notes. So y equals x minus x cubed. And the x bar is going to be easy to figure out. It's the y bar that's interesting. We know the y bar is the sum of the moments about y equals 0 divided by total area. And area is easy here. This graph starts at 0, 0, goes up for a while, and then at 1, 0, gets back. So the area is exactly an application of the very first problems that you solved with integrals. It was the sum from 0 to 1 of x minus x cubed. Thinking back to what we did here, it's our way of calculating y bar was getting the sum of the moments about y equals 0. Which entailed us to draw a horizontal strip because everything here was the same distance from y equals 0. And then I had to solve for x to get the base. So if y is x minus x cubed, what's x? And see, that's a hard algebra problem. So if we tried to copy the method that we did there, so we've got an algebra problem that we don't even train you how to do anymore. At some point, yeah, before calculus was invented, did you know Harvard was a school before calculus was invented? At some point, right, math people needed to do some sort of math. Keep the students busy, they teach them how to solve equations like that. So now we have more interesting. So the last thing I need to show you is how to do the y bar with a vertical strip. And so here's the problem. Here is the y equals 0 line, just like we had here. Here is our strip. The way we do the calculation is we do the distance from y equals 0 times the area. The reason we chose a horizontal strip there because every point on the horizontal strip had the same distance. Here, though, is we have a bunch of different distances. That is the one problem we need to solve. This actually happened to Newton as well. So have you heard the story about the apple falling on Newton's head? Anyway, there's a famous story that is true even though it didn't happen. So an apple didn't really hit him on the head. So the idea, the moral of the story is true. So what happened was Cambridge, Newton was 23, he was in graduate school. It's because of the plague, everybody was getting sick and dying, they closed school for a while. And Newton went back home to the family farm when he was 23. and he invented modern physics, so physics, the way we do it now, our first approximation to how we do it now, and he invented calculus in order to do the physics that he had just invented. And his light bulb moment, or as the is told, is he was sitting under the tree thinking. And well, he was thinking about, I've got the Earth here and the moon here. And we know the moon goes around the Earth. And then when the apple fell on his head, he realized that the force that's drawing the apple to the ground is exactly the same force that's keeping the moon rotating around the Earth. Essentially, he invented gravity, discovered, invented, I think what call it, gravity. And he figured out that gravity is going to depend on two things. It's going to depend on how massive these are. The more massive they are, the greater the attraction.